Hello everyone, this is the fourth video regarding the finite element analysis and design of the ultrasonic cleaners. In the previous video we finished defining the properties and assigning it to different parts of the ultrasonic cleaner. In the next part I'm going to assemble all these stuffs. We need one back mass, one electrode, then one PZD, another electrode, another PZD, another electrode, and the front drive, and also a bolt. Okay, rotate it a little bit, go here. Now I have to define the constraint. The first one is the face-to-face constraint between the back face of this one and the front face of this one. Make sure the arrows are in the same direction. Okay, and the distance between these two should be 0. And then I also define the coaxial constraint between these two with the same direction of arrows. Then, as you see, the radius of the back drive and also the washer is not the same, or the electrode is not the same, because the bolt is in contact with the back drive and front drive, but it's not in contact with the piezoelectric discs and also the washers. Okay, the same procedure is going to be done between these two. Flip, okay, 0, and coaxial, okay, and then face to face between these two, flip, and coaxial, okay. Then one more time, flip, okay, 0, and coaxial between these two, and these two, flip, okay, 0, and coaxial, and finally these two faces with the flip, okay, 0, and coaxial, you'll see how I did it. Flip, okay, and then the next part is again face to face, this face and this face. I have to flip, okay, 0, and the final coaxial stuff is going to be between these two. Okay, the whole thing is modeled and assembled. The next part I'm going to define these steps. The first step that I'm going to use is the static step. General static step, nonlinear geometry is on, total period 1, you can use the automatic one, 0.00, let's start 0.01 minus 15, and 0.01, the minimum and maximum. Yeah, the automatic, it can go very high. So the nonlinear geometry is on. Okay, this is the static. In this static general, why do I need it? Because first I want to apply the bolt preload in this one. So the bolt preload is being applied, and then we do the modal analysis to see what is the first natural frequency of this component. You know that if the bolt load changes, the modal properties of this system of transducers changes. So first we have to apply the bolt load. Okay, and then we create another step, which is the linear perturbation frequency step, which is the modal analysis. I'll call it modal analysis. The previous one should be called the bolt preload. So the minimum frequency is, I assume to be 10 kilohertz, and the maximum like 40 kilohertz. Okay, the whole natural frequencies and mode shapes will be, which will be between these two frequency ranges, will be calculated in this step. Okay, I rename this one to be bold preload. Okay. So we go to the. I think that's enough for now. In the next video, I'm continuing this one.